Okay, so for the first problem on this review, it wants me to determine whether it's a solution to the systems of the equations. So what I'm going to do is I'm going to plug in each value for x and y into both equations and then check to see if it works in the equation. So I have 8 times 1/2 plus 7, not 7, I don't know where I got that 7 from, plus 3 equals 7. So 8 times 1/2 is 4. 4 plus 3 equals 7. That's a good step. I'm going to go check the second equation. Now I have 4 times 1/2 plus 3 times 3 should equal 11. Then 4 times 1/2 gives me 2. 3 times 3 gives me 9. 2 plus 9 equals 11. I'm good there. This one is a solution. For number B, I'm going to do the same thing. I'm going to go ahead and plug them in. I have 8 times 2 plus 1/3 equals 7. 8 times 2 is 16 plus 1/3 equals 7. Definitely not going to work. Not a solution. I don't even need to check the second one if the first one already doesn't work. Okay. Number 2 gives me a system of linear equations down below and then wants me to classify the system as consistent dependent, consistent independent, or inconsistent. It also gives me a picture of the graph with them. So for part A, this one is the same line. This one is consistent and then dependent because they're the same line. Consistent, dependent. And then when it's consistent dependent, I have an equation for my answer. This one is going to be y equals negative 3x. For B, if I go ahead and look at those are two separate lines. That means they're also parallel. That means they're never going to touch. So this one is inconsistent. Over here for C, they touch at exactly one point. So this is consistent independent. Consistent, independent. Then the answer here is where they cross. If I look closely, this is counting by 2's, so this is 2, 0. Okay. There we go. Number 3 wants me to graph the system below and write its solution. If I am graphing by hand, what I want to do is I want to get everything equal to y. So I'm going to start by changing my second equation by subtracting 3x on both sides. I end up with negative y equals negative 3x minus 6. Then I want to make it positive, so I divide everything by negative 1. I get y equals 3x plus 6. I'm going to go ahead and graph those two. So for my first equation, I go up 1. And then my slope is negative 2, so I go down 2 over 1. And then I want to go ahead and connect the points. I am going to draw a line. Okay. Then I'm going to go ahead and graph my second graph. Over here, oops, this one is 3x plus 6. So I'm going to go ahead and go 1, 2, 3, 1, 2, 3, 4, 5, 6. And then my slope is up 3 over 1. That would take me off the graph if I go to the right, so I can also go down 3, left 1. 1, 2, 3, which is right here. If I take a look, it's where my two lines cross, so this is also my answer. It's negative 1, positive 3. Okay, number 4 wants me to use substitution to solve the system. What I'm going to do here is I am going to want to solve one of my variables or isolate one of my variables so I can plug it into the equation. If I look here, this equation is already solved for y, so I'm going to go ahead and plug it into the y for the second equation. So I'm plugging in x minus 3 for the y in my second equation, plus 2x equals 9. Then I want to go ahead, and since it's just addition, I'm going to combine like terms. X plus 2x is 3x. And then I want to solve for x, so I want to start by adding 3 to both sides. I have 3x equals 12. Divide both sides by 3. X equals 4. There are 2 parts to my answer because I have to have a coordinate point. What I'm going to do is I'm going to take x equals 4 and I'm going to plug in 4 for one of my x values in either of the 2 original equations. I'm going to pick the top one because it's going to give my answer straight out. So I am plugging in 4 here. 4 minus 3 is 1. So my final solution here is 4, 1. Okay. Number 5 wants me to solve the following system of equations. If I notice my y variables have the opposite sign and same coefficient, so this makes the perfect case for using the elimination method. I add straight down for this method. 4 plus 5 is 9. The 3's cancel out. 1 minus 19 is negative 18. Then I want to divide both sides by 9. I get x equals negative 2. I'm going to plug into one of my 2 original equations. They both look about as difficult, so I am going to just plug it into my first equation. 4 times negative 2 gives me negative 8 minus 3y equals 1. Then I want to add 8 to both sides. I have negative 3y equals positive 9. Divide both sides by negative 3. I end up with y equals negative 3. So my coordinate point is negative 2, negative 3. Okay. For number 6, I want to solve this and get one of my variables alone. If I notice both of them have different coefficients, and none of them have opposite signs. So I am actually going to look for something that both numbers multiply, or both coefficients of my desired variable that I want to cancel out multiply to. So if I take a look, I have 4 and 6 for my x terms. So what I'm going to do is I'm going to both turn those into 12. For the top equation, I need to multiply by 3. 4 times 3 is 12x. 3 times negative 3x is negative y is 3 times negative 3y is negative 9y. 3 times 24 is 72. On the bottom, I'm going to multiply by negative 2, so they have an opposite sign. Negative 2 times 6x is negative 12x. Negative 2 times negative 5y is positive 10y. Negative 2 times 38 is negative 76. Then I want to go ahead and combine these two. I'm going to add straight down. The 12x's cancel out. Negative 9y plus 10y equals y. 72 minus 76 gives me negative 4. I have my y already, so I get to go back and plug in. I'm going to pick the first equation because they both look equally as difficult to plug in. I have 4x. Negative 3 times negative 4 gives me positive 12. Then I want to subtract 12 from both sides. I have 4x equals 12. Divide by 4. And I end up with x equals 3. Remember, the coordinate points are always in the form x, y. So x goes first, and then my y term. And that is my answer here. Okay. So for number 7, it gives me 2 systems of equations, and it wants me to write its description of its solution, and then if possible, give the solutions. So for the first one, I'm going to use elimination because I notice my x's are opposite signs. I'm going to add down. The x's cancel out. The y's cancel out, so it gives me 0 on the left. 7 minus 4 equals 3. It's not the same. This one is inconsistent. Over here on B, the x's are also opposite signs, so I'm going to go ahead and add straight down again. The x's cancel, the y's cancel, that gives me 0. 9 minus 9 gives me 0. This one is consistent. And then it's dependent because it didn't give me an exact answer. What I want to do when it's consistent dependent is I want to write it as a coordinate point. I am going to pick my top equation to solve. I have x minus 7y equals 9. I am going to solve for the variable x here, so I add 7y to both sides. I get x equals 7y plus 9. So when I go to write my coordinate point, it's in terms of y. I have 7y plus 9 for my x value, and y for my y value. On number 8, it says the sum of two numbers is 24. One number is 3 times as large as the other. What are the numbers? So I have x plus y equals 24. And then 3 times a number equals the other. So the way I wrote this, I have it as one variable is already isolated. So I can go ahead and plug in the 3x for the y on the top equation. So I have x plus 3x equals 24. X plus 3x is 4x. Then I want to divide both sides by 4. I get x equals 6. Since I'm just looking for numbers, I don't have to write this as a coordinate point. Then I'm going to go ahead and plug into one of my equations. I'm just going to pick the bottom one. So I have y equals 3 times 6, which gives me 18. Okay. Number 9 wants me to solve the following system. What I do here is I notice that it has x in an equation where there's no other variables. So I'm going to solve for each variable and then move on. So 3x equals 6 is going to be the first equation I solve. I divide both sides by 3. I get x equals 2. So then I'm going to take my x equals 2 and plug into the second equation right there. So I have 4 times 2 minus y equals 3. 4 times 2 is 8. Then I want to get the 8 over to the other side. I have negative y equals negative 5. Divide both sides by negative 1. I get y equals 5. Then I'm going to go ahead and plug into my bottom equation. So I have 2 for x, 5 for y, and then plus 2z equals negative 1. I want to solve for z here, so I can start by combining like terms. I have 7 plus 2z equals negative 1. I want to subtract 7 on both sides. I get 2z equals negative 8. Then I divide both sides by 2, and I get z equals negative 4. So just like before, when I wrote my coordinate points in alphabetical order, this one still gets written in alphabetical order. I have positive 2, positive 5, negative 4. Number 10 wants me to solve this system. What I want to do here is, since I have 3 variables, I want to get it down to two variable equations to solve. So I am going to start by combining the first 2 together to get rid of x because they're opposite signs and it makes it easier to cancel out. So I will end up canceling out my x's. I have 2y plus z equals negative 3. And then I am going to work with the first equation and my bottom equation. For my first equation, since it's opposite sign, I just need to multiply by the coefficient to make it the same. So I have negative 2x plus 2y plus 4z equals negative 20. And then I'm combining it with the bottom equation, so I'll rewrite that down below. Okay. Then when I go ahead and solve this, the x's cancel out. I have 3y plus 5z equals negative 15. So I'm going to write that here. I want to cancel out another variable. The variable I am going to look at is z because that has a coefficient of 1. So I'm going to multiply both the top equation by negative 5. It's going to give me negative 10y minus 5z equals positive 15. So when I go to add those 2 equations, I have negative 7y, the z's cancel out, equals 0. Divide by negative 7, and I get y equals 0. now what I want to do is I want to go ahead and plug back into one of the two equations I had earlier, the 2y and the 3y, and solve for z, so I can go back to one of my original equations and solve for the x value. I am going to pick the top one. It doesn't really matter. So I have 2, and then in here I'm plugging in 0, plus z equals -3, 0 plus z equals -3, z equals -3. I can pick one of the 3 original equations to solve back for x. I'm going to pick the middle one since there's not a lot of coefficients. So I have x plus y was 0, minus z was -3, equals 7. So I have x, -3 is +3, and the 0 just disappears. Then I subtract 3 on both sides, and I get x equals 4. So I go ahead and I write my coordinate point. It's going to be 4, 0, -3. Okay. This one gives me the system. It wants me to write the best description of its solution, and if possible, give the solution. So over here, it's going to work out just like the other one. I am going to cancel out x's because I'm going to first put the 2 to get the 2 with the x's. I'm going to multiply the bottom one by -1. So the top one I'm just going to leave alone. The bottom one is going to be -x minus y plus 2z equals -5. When I add those together, the x's cancel out. I have a y, I have a -z, and I have a -4. I'm going to put the top 2 together by multiplying the top one by -3. So I'm going to have -3x minus 6y plus 9z equals -3. Then I have 3x plus 5y minus 8z equals 7. If I go and add those, the x's cancel out. I have -y plus z equals 4. If I go over here, I can combine the two. My y's are opposite, they cancel out. My z's are opposite, they cancel out. My 4's are opposite, they cancel out. So this one is consistent dependent. Then I need to solve. Since I already have these 2 equations, I want to pick one of them to solve for a variable. I will solve in terms of z. Oops. So I'm picking the top equation to rewrite. I have y minus z equals -4. If I add z to both sides, I get y equals -4 plus z. Then I want to plug back into one of my original 3 equations to solve for x. I'm going to pick the bottom one since I don't have to multiply y by anything. I have x plus -4 plus z minus 2z equals 5. So if I combine like terms, I have x minus 4, z minus 2z is -z equals 5. I add 4 and I add z to both sides. And I get x equals 9 plus z. Then to write my answer, I'm going to go ahead and write it. So I have 9 plus z for x. I had -4 plus z for y, and z for z. Okay. Number 12 gives me the following system of linear equations. It wants me to follow the steps and write it, and then part A wants me to write the augmented matrix. So that is just writing the coefficients of the equation. Okay. Over here for part B, it wants me to solve it, and it tells me over here that I'm going to end up with a coefficient of 1, so I need to figure out what I multiplied my first row of my equation by to turn it into 1. it's going to be 1/4. So 1/4 times 4 is 1. 1/4 times negative 8 is negative 2. 1/4 times 12 is 3. The bottom row is not changing. 7, 4, 3. Then I want to figure out what I have to multiply the first row by to cancel it out with the second row. That would be negative 7. I'm going to do some scratch work over here. So I have negative 7. Negative 7 times negative 2 is positive 14. Negative 7 times 3 is negative 21. And then I'm adding it with that bottom row. So the 7s will cancel out. And I will be left with 18 and negative 18. The top row is the same from the line above, so I still have the negative 2 and the 3. The next step, I want to turn the bottom number into 1, so I need to figure out what I multiply 18 by to turn it into 1. That is going to be 1/18. My top row stays the same. 18 times 1/18 is 1. Negative 18 times 1/18 is negative 1. Then I want to figure out what I'm multiplying the bottom row by to turn it into the second value from the top row. This would just be a positive 2 because they're already opposite signs. I'm going to show my scratch work here. So I have 1, negative 2, 3. And then I'm multiplying the bottom by 2, so I have 0, 2, negative 2. When I combine those, the second value cancels out. 3 minus 2 is 1, and I have negative 1. So my solution here is 1, negative 1. Okay. This one gives me two augmented matrices for linear systems in the variables x, y, and z. The augmented matrices are in reduced row echelon form, and for each system it wants me to write the best description of its solutions, and if applicable, give the solutions. So notice this bottom row is 0 equals 0. This one is consistent dependent. Then I'm going to start off with what I do know. I have 1 and 4. Since the 1 is in the x position, this means x equals 4. For the second row, I have y plus 2z equals 6. I want to solve in terms of one variable. I'm just going to make it z because y is already isolated. So I subtract 2z from both sides. I have y equals negative 2z plus 6. So when I go to write my coordinate point, I have 4. And then I'm going to have negative 2z plus 6, comma, z. Because z is the unknown variable. If I take a look at b, I have 0 on one side and 5 on the other. This one is inconsistent. For number 14, I'm doing scalar multiplication, so I want to multiply each term in the matrix by negative 2. So I have negative 2 times 5, negative 2 times 8, negative 2 times negative 1, negative 2 times 3, negative 2 times 2, negative 2 times 3. And then I just want to go ahead and simplify. I have negative 10, negative 16, positive 2, negative 6, negative 4, negative 6. And that one is done. Number 15 is just finding subtraction between the two matrices. They are the same size, so subtraction is possible. I'm going to have 6 minus negative 8, negative 2 minus 1, 13 minus 8. Then I have negative 3 minus 2, 7 minus 5, 0 minus 9. I want to go ahead and subtract. 6 minus negative 8 is 14. Negative 2 minus 1 is negative 3. 13 minus 8 is 5. 3 minus negative 2 is negative 5. 7 minus 5 is 2. 0 minus 9 is negative 9. And I am done for that one. Number 16 wants me to do scalar multiplication and then combine like terms. On the first one, I'm going to multiply by negative 3. So I have negative 3 times negative 2, negative 3 times 7, negative 3 times 3, negative 3 times 4. And then I will be adding that to 4 times d. So I have 4 times 0, 4 times 1, 4 times 4, and 4 times negative 5. I'm going to go ahead and do the math inside each of my matrices. Negative 3 times negative 2 is 6. Negative 3 times positive 7 is negative 21. Negative 3 times 3 is negative 9. Negative 3 times 4 is negative 12. I have 4 times 0, which is 0. 4 times 4, which is 16. 4 times 1, which is 4. 4 times negative 5, which gives me negative 20. Then I want to go ahead and add those. So I have 6 plus 0, negative 21 plus 16, negative 9 plus 4, negative 12 plus negative 20. When I add those, 6 plus 0 gives me 6. Negative 21 plus 16 gives me negative 5. Negative 9 plus 4 gives me negative 5. Negative 12 minus 20 gives me negative 32. Okay. B wants me to do matrix multiplication. The first one is doing B times C. So I multiply B's rows with C's columns. I have 9 times 5 minus 4 times negative 7. Then I have 9 times 0 minus 4 times 3. Then I am going to do the bottom row times the columns. So I have 1 times 5 plus 3, I don't know where that 3 came from. It should have been negative 7. And then over here, I have 1 times 0 plus 3 times 3. Then I just want to simplify those. So 9 times 5 is 45. Negative 4 minus 27 is 28. 9 times 0 is 0. Negative 4 times 3 is negative 12. 1 times 5 is 5. 3 times negative 7 is negative 21. 1 times 0 is 0. 3 times 3 is 9. Then I just combine. So I want to go ahead and add 45 and 28, which gives me 73. 0 minus 12 is negative 12. 5 minus 21 is negative 16. And 0 plus 9 is 9. For C times B, I'm doing this in the other order. So I'm having 5, 0, negative 7, 3. And I'm multiplying by 9, negative 4, 1, 3. So I'm multiplying the rows from the first one with the columns of the second one. I'm going to have 5 times 9 plus 0 times 1. Then I have 5 times negative 4 plus 0 times 3. On the bottom, I have negative 7 times 9 plus 3 times 1. And then on the other corner, I have negative 7 times negative 4 plus 3 times 3. Then I want to go ahead and simplify each part. 5 times 9 is 45. 0 times 1 is 0. 5 times negative 4 is negative 20. 0 times 3 is 0. Negative 7 times 9 is negative 63. 3 times 1 is 3. Negative 7 times negative 4 is positive 28. 3 times 3 is 9. Then I want to add 45 plus 0 is 45. Negative 20 plus 0 is negative 20. Negative 63 plus 3 is negative 60. 28 plus 9 is 37. Okay, then for C, it's doing B squared, so this means I'm multiplying 2 of the B matrices together. So I have 9, negative 4, 1, 3, times 9, negative 4, 1, 3. So I'm going to do these rows with these columns. I have 9 times 9 minus 4 times 1. Then I have 9 times negative 4 minus 4 times 3. On the bottom, I have 1 times 9 plus 3 times 1. And I have 1 times negative 4 plus 3 times 3. Then what I want to do is I want to go ahead and simplify. 9 times 9 is 81. Negative 4 times 1 is minus 4. 9 times negative 4 is negative 36. Negative 4 times 3 is 12. 1 times 9 is 9. 3 times 1 is 3. 1 times negative 4 is negative 4. And 3 times 3 is 9. 81 minus 4 is 77. Negative 36 plus 12 is negative 24. And on the bottom I have 9 plus 3, which is 12. Negative 4 plus 9, which gives me 5. Okay, on the bottom it wants me to do the matrix multiplication if it exists. I have a 2 by 3 and a 3 by 2, so they do 3 by 2 and 2 by 3, so they do work up. I'm going to have 6 times 8 plus 1 times 0. Then I'm going to have 6 times 1 plus 1 times negative 4. 6 times 3 plus 1 times negative 5. Next row, I'm going to have negative 2 times 8 plus 2 times 0. Then on the next row, I have negative 2 times 1 plus 2 times negative 4. Next row, next piece, I have negative 2 times 3 plus 2 times negative 5. Final row, I have 7 times 8 plus 3 times 0. Then I have 7 times 1 plus 3 times negative 4. And the final piece, I have 7 times 3 plus 3 times negative 5. Then I want to go ahead and simplify my math. 6 times 8 is 48. 1 times 0 is 0. 6 times 1 is 6. 1 times negative 4 is negative 4. 6 times 3 is 18. 1 times negative 5 is negative 5. Negative 2 times 8 is negative 16. 2 times 0 is 0. Negative 2 times 1 is negative 2. 2 times negative 4 is negative 8. Negative 2 times 3 is negative 6. 2 times negative 5 is negative 10. 7 times 8 is 56. 3 times 0 is 0. 7 times 1 is 7. 3 times negative 4 is negative 12. 7 times 3 is 21. And 3 times negative 5 is negative 15. Then for my final piece, I just want to go ahead and combine. 48 plus 0 is 48. 6 minus 4 is 2. 18 minus 5 is 13. Negative 16 plus 0 is negative 16. Negative 2 minus 8 is negative 10. Negative 6 minus 10, oops, I wrote that in the wrong spot. Negative 6 minus 10 is negative 16. 56 plus 0 is 56. 7 minus 12 is negative 5. And 21 minus 15 is 6.